So if you can't stay after school, who do you have for period 3? Okay. I think we had that conversation yesterday, and you said that he probably would let you come in here, right? Okay. All right. So today we're going to solve equations by taking square roots. So shut it. Aiden, do you need to come stand by me? Then shut up. Okay. So the first thing I want to talk to you guys about is simplifying equations or solving equations. When you learned how to solve an equation, you learned that you have to solve equations by using the inverse of your order of operations, right? So let's talk about what is the order of operations first. PEMDAS. So you remember, if you're solving an equation, the first thing that you do is undo addition or subtraction. The second thing you do is undo multiply or divide. You guys know how to solve equations. That's really all we're doing. That's all we've been doing. When you solve an equation, your goal is to do what? Yeah, say it.
Isolate the variable.
Yeah, isolate the variable. That's what we're doing. We're isolating the variable. That just means get the variable alone. That's all it means. Get the variable alone. So I have 3 very different equations here. 3 very different equations. The first one, Chandler, are you taking notes with us? Okay. The first equation, 2x minus 1 equals 11. So I wanted to solve that equation. I wanted to isolate the variable and solve that equation. What would I do first, Quali? Trying to get x all by itself. What do I have to move away first, Quali? What do I have to move away first? Yeah, I have to add 1 to both sides, right? This is a 2-step equation. I'm trying to get the variable alone. So the first thing I'm going to do is add 1 to both sides. So I have 2x equals 31 plus 1 is 32. Now what am I going to do? You're confused about what? No. This is not a quadratic. This is a linear equation. There's no x squared. Do you see that? There's no x squared. This is a linear equation. This is a 2-step equation. So I'm not, do you see that, Quali? Maybe you didn't see that at the beginning. This is a linear function. This is not x squared. This is linear. Okay. So now I'm going to divide both sides by, and x equals 16. Okay. That's just a 2-step equation. All right. Now, when I look at my next example, we're solving all of these by taking square roots. We're going to solve all of these by taking the square root. So every single time I'm trying to isolate the variable. Every single time I'm trying to isolate the variable. So I'm still going to add 1 to both sides. And that gives me 2x squared equals 32. Still trying to get x all by itself. So what do I do first? Undo, multiply, and divide. X squared equals 16. If you think back about order of operations, the last thing that you do is one of the first things, right? You're supposed to take care of exponents, but now we have to undo that exponent. No. How do we unsquare something? You find the square root of it. Okay. That's all right. So I have a question. What is the square root of 16? It's 4. Is the square root of 16 also negative 4? Because remember that negative 4 times negative 4 equals what? 16. So how do we show that it's both a positive and a negative? Yeah. Okay, hang on a second. Quali, listen up. We're just solving this by taking the square root. So you know that you can put into your calculator the square root of 16, right? The square root, this is what this is saying. What, it's a square. This is a square. What two numbers do you multiply together to get positive 16? 4, right? So that means that x equals 4. But I said, well, what if those two numbers were -4 and -4? Isn't -4 times -4 also 16? So that means that your answer is both +4 and -4. So we said you can write it like this. Yeah. Absolutely, write it the first way. Okay. This is why when we factor a quadratic, it has two answers, right? The positive, typically a positive and a negative one. Okay. All right, let's look at this one. A little bit different, still the same concept. We're trying to get the variable all by itself. So what would I do first? Add the 1. Yeah, we're going to add 1 to both sides. So 2 times the quantity of x minus 3, the quantity squared, equals 32. Now what? This says 2 times the parenthesis. What's the undo of times? Divide. So I'm going to divide both sides by 2. That gets rid of the multiply. So now I have x minus 3, the quantity squared, equals 16. How do I get rid of the 2 on the outside? I divide. I didn't FOIL it out. I can't do 2 times x because that x is in a parenthesis, right? And that parenthesis is being squared. Nope, I'm not FOILing that out. I'm leaving that just the way it is for a second. So do you see what I have now? Division. Dividing both sides by 2. So now over here, when we ended up with something squared, how did we get rid of it? How did we unsquare something? We took the square root of it. So how do I unsquare x minus 3, the quantity squared? I take the square root of it. But remember, whatever you do on one side, you have to do to the other side. So the square root of x minus 3, the quantity squared, that just makes that squared go away. So now I just have x minus 3. And I know that the square root of 16 is both a positive and a negative number. So this we have to separate and solve. We have to separate this and solve. We either have that x minus 3 equals positive 4, but we also have that x minus 3 equals negative 4. So how am I going to solve that? How am I going to get x all by itself? Add 3. So when I add 3 on the first equation, I find out that x equals 7. When I add 3 on the second side, I find out that x equals what? Negative 1. Let's check because I feel like you guys are the definition of our lesson today. What is our lesson called today? Solving by taking roots. We're taking square roots. We're solving quadratics by taking the square root. You can't always do this, but it is another method. right? It's just another method. So today we're using solving by taking square roots. Let's check our two answers, 7 and -1. So if I wanted to check those, oh, that's our timer for our quizzes. If I wanted to check those, I would just substitute in 7. But I would also substitute in the answer -1. Wasn't that our other answer? Those are the values that we got for x, right? So let's go to the first one. What is 7 minus 3? 4. What is 4 squared? 16. So I have 2 times 16 minus 1 equals 31. What is 2 times 16? 32. What's 32 minus 1? So 31 equals 31, right? So x equals 7 works. That's a good answer. Let's check the next one. What is -4 minus 3? Or sorry, -1 minus 3. What does this become? It becomes -4. What is -4 the quantity squared? So I have 2 times 16 minus 1 equals 31. What's 2 times 16? And 32 minus 1 equals 31. So today's lesson is to solve by taking square roots. So that's what we're going to do the whole time. We're going to keep taking square roots. That's why yesterday we learned how to simplify a radical first, because sometimes you're going to get an answer that's underneath the radical that you can simplify. You're going to get a square root that you need to simplify. Okay? Are you with me? Okay, so here are your steps. So let's simplify radical reveal really fast. What do I do to this first one? How can I simplify the square root of 72? Look at your times table. Oh, okay, so this is the same thing as the square root of 9 times the square root of 8. What is the square root of 9? 3, okay. Does 8 have a perfect square in it? Yeah, it does. What's 8 the same thing as? Square root of 4 times the square root of? What is the square root of 4? So I end up with 3 times 2 times the square root of 2, which is 6 square root of 2. What about 1 over the square root of 1/2? What's the problem with that? Yeah, we can't have that radical in the denominator. That's mathematically gross. How do I get rid of it? Yeah, we multiply by the denominator. We multiply by 1. All I'm doing is multiplying by 1. TJ, are you taking notes or are you taking a nap? Okay, we multiply by 1. The square root of 2 over the square root of 2 is just a fancy looking number 1. That's all that is. 1 times the square root of 2 is the square root of 2. And the square root of 2 times the square root of 2 is what? It's 2. Because the square root of 2 times the square root of 2 is the square root of 4. Remember we said that yesterday, which equals 2. So does everybody see that? What about when I have a fraction underneath the radical? What's the first thing that we need to do? You guys remember? Break it up, right? So the square root of 144 divided by 9 is the same thing as the square root of 144 over the square root of 9. Whoops. So what is the square root of 144? 12. And what is the square root of 9? And can I reduce that? What to what? To 4. Last one. So I have the square root of 8 divided by 20, which is the same thing as the square root of 8 divided by the square root of 20. Can I write 8 as a product of a perfect square? The square root of 8 is the same thing as what? The square root of 4 times the square root of 2. What is the square root of 20 the same thing as? Square root of 4 times the square root of 5, right? What do you see in this fraction right here? What do you see that I can reduce? What do I have the same of in the numerator and in the denominator? Yeah, I have the square root of 4, which is the same thing as 2. I'm just dividing it by 2. So my final answer right now is the square root of 2 over the square root of 5. Can I leave it like that? Why not? Can't have a square root in the denominator, so I have to multiply by that fancy looking 1, the square root of 5 over the square root of 5. 2 times 5 is 10. So I have the square root of 10 over the square root of 5 times the square root of 5 is 5. Okay. So let's talk about steps to solving using square roots. So you're always going to isolate x squared or the sum or difference of a binomial squared. A can be any rational number. Then use the square root to remove the power of 2. So 4 squared under the square root symbol is just what? What does the square root do to the square? It cancels them out. It equals 4. Well, I don't believe that, and neither does Haley. So what is 4 squared? 4 times 2. 4 is what? No, not 4 times 2. 4 squared. 4 times 4 is 16. But the square root of 16 is what? 4. So all I did is show you that the square root of a number squared cancels out that square. Do you guys see that? They cancel each other out. They're inverses. Do you guys see what's happening? Okay. So you're always going to have 2 possible solutions, a positive one and a negative one. You have 2 roots, the positive and the negative. Okay. So let's just try that. Let's just try that idea. So we're trying to get x squared or something in a parenthesis squared all by itself. So our first example, do I already have x squared isolated? Yes, I do. So how do I cancel out something squared? Take the square root of it. But with all properties of equality, whatever I do on one side, I have to do on the other. The square root of x squared is x, and the square root of 100 is 10, or negative 10, because you have a positive and a negative, right? 10 times 10 is 100, and negative 10 times negative 10 is also 100. Okay. Let's look at example 2. X squared equals 7. Do I have x squared all by itself? Okay. So in order to get rid of that x squared, I have to cancel it out with the square root. Whatever I do on one side, I have to do on the other. So x equals the positive square root of 7 or negative square root of 7. And you can write them like this. If you want, you can write it like this: plus or minus the square root of 7. X equals plus or minus this 10. Sorry, not square root, but x equals plus or minus 10. You don't have to. You can list them out, but you can write it like that. Example number 3. This is why we practiced simplifying radicals yesterday. When I take the square root of both sides, I have x equals, well, the square root of 20 can be broken down into what? Yeah, the square root of 4 times the square root of 5. But what is the square root of 4? 2. So my answer is 2 root 5. But remember, I have a positive 2 root 5, and I have a negative 2 times the square root of 5. Jose, are you taking notes or are you taking a nap? TJ, is your pencil moving or are you napping? Pick your head up. Okay, example number 4. So I have to get x squared all by itself. What do I need to do? That says 6 times x squared. What's the undo of times? Divide. Vanessa, are you taking notes? Pick up your pencil. Divide both sides by 6. So x squared equals, what's 48 divided by 6? 8. Okay. Now what am I going to do? Yeah, I have to take the square root of both sides. So x equals a positive or a negative. How can I break up the square root of 8? It's the same thing as the square root of 4 times the square root of, but what is the square root of 4? 2 times the square root of 2. So plus or minus 2 root 2. Let's look at example number 5. Trying to get x squared alone. What do I need to do first? Divide by 4. So x squared equals 121 over 4. To get x squared unsquared, I have to take the square root of it, but whatever I do to one side, I have to do to the other. How do we write the square root of a fraction? What do we do to that? We break it up, right? Square root of 121 over the square root of 4. Remember, this is a positive and a negative. Does anyone know what the square root of 121 is? 11. And what is the square root of 4? So x is plus or minus 11 halves. X is plus or minus 11 halves. Example number 6. What should we do? Both sides. That says 9 times x squared. Divide by 9. The undo of multiply is divide. So x squared equals 6. Take the square root of both sides. X equals positive square root of 6 and negative square root of 6. Yeah, there are no perfect squares that live inside of 6, correct? What about number 7? Say again. Yeah, good job. I'm going to add 25 to both sides. So 9x squared equals 25. Next step. Divide both sides by 9. So x squared equals 25 over 9. Now what? What do I have to do to both sides? Square root it. Remember that 25 over 9, that can be broken up into the square root of 25 over the square root of 9. And I have both a positive and a negative answer. What is the square root of 25? 5. And what is the square root of 9? 3. Number 8. Someone other than Quali or Haley. Caleb, tell me what to do first. Add 20 to both sides. So 3x squared equals 20. 8 and t, what am I going to do next? Divide both sides by 3. X squared equals 20 over 3. 8 and r, what am I going to do next? Yeah, take the square root of both sides. So x equals plus or minus the square root of 20 over the square root of 3. How can I break up 20 with a perfect square? The square root of 20 is the same thing as the product of what? Square root of 4 times the square root of 5 over the square root of 3. What is the square root of 4? So I have 2 times the square root of 5 over the square root of 3. Can I leave it like that? Why? Square root in the denominator. I have to rationalize the denominator. That's what that's called. So my final answer, x equals plus or minus, let's see. I have the whole number 2, and the square root of 5 times the square root of 3 is the square root of 15 over the square root of 3 times the square root of 3 is 3. I'm going to skip number 9 and I'm going to jump down to number 10. I'm going to skip number 9 and I'm going to jump down to number 10. Okay, remember I either want to get x squared all by itself or the quantity of something squared all by itself. Do I have that? Do I have a parenthesis grouping squared all by itself? Yep, I do. So how do I get rid of that square? Square root it. Whatever I do to one side, I have to do to the other. So when I do that, that gives me x plus 1 equals plus or minus, what is the square root of 16? 4. So now we have to solve that into 2 problems. That means that x plus 1 is positive 4, or x plus 1 is negative 4. Just like our example. So what am I going to do to both sides? Subtract 1. So x equals 3, and subtract 1, x equals 5. Ooh, that's a negative 5, right? Yeah. Let's go to example number 11. Example number 11. Do I already have a parenthesis or a grouping squared isolated all by itself? Yes, I do. So I just have to unsquare it. Take the square root of it. Whatever you do to one side, you have to do to the other. So that leaves me with x minus 3 equals plus or minus the square root of 12. Let's break that square root of 12 up. Square root of 12 is the same thing as the square root of 4 times the square root of 3. But what is the square root of 4? So the square root of 12 is really 2 times the square root of 3. That looks horrible, sorry. 2 times the square root of 3. So x minus 3 equals a positive 2 times the square root of 3. And x minus 3 equals a negative 2 times the square root of 3. Either way, we have to simplify. We have to get that minus 3 gone. I'm going to do that by adding 3 to both sides. So x equals positive 3 minus 2 root 3. And when I add 3 over here, x equals positive 3 plus 2 root 3. These are exact answers. Like, the reason that we have to know how to simplify a radical is because these are exact roots. We don't know how to graph that exact root without technology, but those are exact. Those are exact solutions. When you put it into a calculator, it would give you a decimal. That would be like a rounded answer, right? Let's go down to number 13. Let's go down to number 13. Okay. So I want you to think about when we talked about perfect square trinomials. When we talked about perfect square trinomials, I think that this trinomial right here is actually a binomial squared. How did we figure that out? Do you guys remember how we did that? Well, we said, what's half of 8? What's half of 8? 4. So I'm going to put x minus 4 inside the parenthesis, right? X minus 4 inside the parenthesis. And I want to check it. So when I take 4 and I square it, it better equal 16. And does it? Yeah. So this is a perfect square trinomial. X minus 4, the quantity squared, equals 1. So this looks exactly like the problems that we did up top. How do I solve? Square root both sides. Good job. So that leaves me with x minus 4 equals, and the square root of 1 is 1. So I either have a positive or a negative 1. So x minus 4 equals 1, or x minus 4 equals negative 1. How am I going to solve it? Yeah, add 4 to both sides, and I'm just going to kind of do it all the way across. So x equals 5, and x equals 3. Let's look at example number 14. Can you guys figure out what perfect square trinomial that came from? What binomial squared this trinomial came from? So 6 squared is 36. What about taking the square root of 9? What's that going to give you? 3. Came from 2x plus 3, the quantity squared, and we checked it by taking a times b times 2. 2 times 3 is 6, times 2 gives you your middle term. Do you guys remember that? So 2x plus 3, the quantity squared, equals 2. How do I get rid of that? Square root it. Take the square root of both sides. So that means that 2x plus 3 equals a positive square root of 2 or a negative square root of 2. So that means that 2x plus 3 equals square root of 2, and 2x plus 3 equals negative square root of 2. I'm going to subtract 3 from both sides. And when I do that, I find out that 2x equals negative 3 plus the square root of 2. And I find out that 2x equals negative 3 minus the square root of 2. What do I have to do as the last step? Divide by 2. Divide everything by 2. So my two answers are x equals negative 3 plus the square root of 2 all over 2, and x equals -3 minus the square root of 2 all over 2. Okay. So your homework is the 13 questions on the back, but I do want you to attempt that quizzes first. I do want you to attempt that quizzes. We have our units, like this 2A or 2B test is going to be on Friday. It's going to be on Friday. So I want to give you a quizzes that has 3 attempts to build up your, like, I don't want the second grade in Power School to be not fabulous. Not that I think any of you won't do fabulously, but so I'm going to give you a quizzes today, and then I'll try to do another one on Thursday, just to give you a chance to get some points. Yeah, give me a second.